Welcome to this YouTube tutorial on automatic eye cataract detection using YOLOv8. Before we dive into the coding, let's talk about what an eye cataract is. A cataract is a condition where the lens of your eye, which is normally clear, becomes cloudy, almost like looking through a foggy window. This leads to blurry vision, trouble seeing at night, and sensitivity to light. It's a big deal because cataracts are one of the leading causes of blindness worldwide, affecting millions, especially as we age. In this video, we're going to build an AI-powered system that can detect cataracts in eye images using the powerful YOLOv8 object detection model. Let's see the workflow. Step 1. We'll start by downloading a curated cataract dataset from RoboFlow. This dataset includes labeled images of both healthy and cataract-affected eyes, essential for training our model effectively. Step 2. Using Google Colab, we'll mount Google Drive for easy data access and install key libraries like RoboFlow, Ultralytics, and Gradio. Step 3. Next, we'll fine-tune the YOLOv8 model on our dataset over multiple epochs. This helps the model learn to accurately detect cataracts in eye images. Step 4. After training, we'll evaluate the model's performance using a confusion matrix and metrics like precision, recall, and map to ensure reliable results. Step 5. Finally, we'll build a Gradio web interface, making the system accessible and easy to use. Anyone can upload an eye image and get a real-time prediction with just a click. If you're excited to explore more hands-on AI projects, head over to AI Online Course. There, you'll find a wide collection of real-world projects, complete with full code and live demos. Whether you're working on computer vision, NLP, or deep learning, you can run the code directly on our platform and see instant results. It's a great way to learn by doing and sharpen your skills with practical examples. So, don't just read about it, experience it. Visit AI Online Course and start building today. Now, let's start the project first. We need to mount Google Drive to store our dataset and model weights. This line connects Colab to your drive. Now, we install RoboFlow and download our dataset from RoboFlow, which hosts labeled images of eyes with cataracts. I'm using my API key here. Make sure to replace it with yours. We're accessing a project called Cataract Object Detection and downloading version 3 in YOLOv8 format. Once this runs, you'll see the dataset downloaded to the desired folder in Colab. Next, we install a library, Ultralytics, to use YOLOv8. The Ultralytics.checks function confirms that YOLOv8 is ready to go. You should see a confirmation message with the YOLOv8 version and GPU availability. Here's the exciting part: training our YOLOv8 model. We're using the YOLOv8 N.PT pre-trained model, which is lightweight and perfect for this task. The data parameter points to our dataset's configuration file, data.yaml. We're training for 3 epochs with an image size of 640 by 640 pixels. You can increase the epochs for better accuracy, but for this demo, 3 is enough. This will take a few minutes, and you'll see the training progress with loss values and metrics. Once training is complete, let's check the results. These images are saved in the train folder on my drive. First, we have the confusion matrix. It shows how well our model classifies cataracts versus non-cataracts. Next, the results plot gives us metrics like precision and recall over the epochs. Finally, this training batch image shows some labeled examples that the model was trained on. Pretty cool, right? Now, let's test our model on a new image. We load the best weights from training, which are saved as best.pt. Then, we run inference on a validation image from our dataset. The results object contains the predictions, and we save the output to our drive. Here's the predicted image. Look at those bounding boxes. The model has detected the cataract area in the eye. You can see the label and in the image. Now, we import some libraries for visualizing image. Then we also loaded the best model and result that are stored in Drive. Then we define a function called predictImages that takes uploaded images, runs inference using our trained model, and draws bounding boxes with labels and confidence scores. We use OpenCV to draw the boxes in blue and add text. Finally, let's make our model user-friendly with a Gradio interface. First, we install Gradio. The Gradio interface lets users upload multiple images and see the predictions in a gallery. Run this cell, and you'll get a link to access the interface. Let's upload a few images and see the results. Look at how easy it is to use. And that's it. We've built an end-to-end cataract detection system using YOLOv8, from downloading the dataset to creating a Gradio app. You can now experiment with your own images or extend this project to other tasks. If you found this tutorial helpful, please like, subscribe, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next video.